We were talking about block diagrams as ways to represent systems, more complicated systems. And quickly, block diagrams, the lines in a block diagram and arrows on them were signals. And the boxes were processes which had their own little transfer functions. So here you have an input signal, a process, and an output signal. Call this a system. Signals and systems. Signal goes in, the system converts an input to an output signal, signal comes out. In signal flow graphs, that's another graphical way to represent more complicated systems. In a signal flow graph, these little circles here, these dots or circles, those are nodes, and they are the signals. So this signal here, Y2, is like this Y over here. This Y sub 1 is like this U over here. And then you just label, you connect them with a line, with an arrow. The arrows are significant. And you just label what the process is that takes you from this signal to that signal. So that this is the signal flow diagram. This here is equivalent to that. Let's look at this. You have a signal Y1, and it has a G sub 1 up here. It's the same signal coming out of that, or the same, that's a signal goes into a process, the process does something to it, and it goes into another signal. This signal, Y1, has two branches. One gets multiplied by G1, the other by G2. And when they join like this, these two branches, that means they add. So Y2 is the sum of G1, Y1, and G2, Y1. So that this signal flow diagram is equivalent to this block diagram. Let's look at another one. Here we have a feedback path. We have a signal here, R, then a U, then a big Y. You go from Y to Y by just multiplying by 1 here. Let's see. See this U here? It's going to be the sum of what comes into it. One thing that comes into it is R. The other thing that comes into it is this Y times the minus H. Y, H with a minus sign. That's a feedback path, and here you put the minus sign on the process rather than on the node or the summation. Let's see. This goes at, well, there's the output Y. So that this signal flow graph is equivalent to this block diagram. What if you started with a block diagram and wanted to convert it to a signal flow graph? Let's say you were given this block diagram, the only signals labeled was the output Y and the input R. Let's say these E, Y3, etc. are not there. What you want to do is label every signal in the block diagram. It has one of two features. It either comes right after a summer or comparator, these round things, or it has multiple branches. So let's look at these signals. Here is a summer. What comes after it? You want to label that. We'll call it E. We could have called it something else, but since the PowerPoint was already made, let's call it E. Here is another summer. So we want to label whatever comes after it, the signal. So we call that signal Y sub 3. Here, it's not coming after a summer, directly after a summer, and it only has the one branch. So we don't need to label that guy. Okay, here we have another summer, so we want to label that guy. We call it Y2. And we would have wanted to label it anyway because it has two branches, one going into G2 and one going into G4. We want to label that guy. G2, there's no summer there, but this guy has two branches, one going into G3 and one being fed back to G4. So we want to label this signal like Y1. Okay, not a summer here, no branches. Here's a summer, so we do want to label this guy, but it's the output. What else? Wouldn't need to label, this is already labeled here. Everything coming out, that's Y and that's Y. We need to label them. No summer here, no multiple branches, so we don't need to label this guy. This is Y1, it's already labeled. No summer or multiple branches here, we don't need to label it either. So we've labeled everything, every signal that we need to label. So we lay them all out as nodes on a horizontal line. R1 is a signal, that's a node. E, Y3, Y2, Y1, and Y. E, Y3, Y2, Y1, and Y. And to get a clean output, one more node, just multiply by 1. Now let's see. Let's see, what is E? It is R minus Y. So let's see. We have R coming into it. We need another signal, Y, and it's a minus, so we need to multiply by -1. So you need to label this process here, this line, with a -1. That's what E is. What is Y3? It is E minus H1, Y1. So we need to pick off Y1, multiply by minus H1, and that goes into H3, or Y3, excuse me. Have that. What is Y2? It is G1 times Y3. So here's Y3. We need to multiply by G1. And it also has a minus H2Y fed back into it. So we need to go from Y with a minus H2 to Y2. So this little feedback path here accounts for this feedback path. We've already accounted for this big feedback path, this feedback path, and now this feedback path. So got those three feedback paths. What's one more from Y2 up to Y? It goes through G4, so you got to put the G4 in. That's how you do it. That's the basic of signal flow graphs. We're learning that primarily to get into Mason's rule. And it's going to take many charts to get through Mason's rule. It's a little bit complicated, can be a little tedious, but if you have really complicated block diagrams or signal flow graphs, it's easier than doing it algebraic. This is going to take some time. I'll save it for other videos. So the next step is Mason's rule.